Okay, hi guys, welcome to 5.2, which is the scalar product. So in this subtopic, we will learn scalar product, the properties of scalar product, the angle between two vectors, and the direction cosine and direction angles. Okay, so for scalar product is known as dot product of two vectors. I use A and B. For two vectors A and B, the dot product will be defined as modulus A modulus B cos theta. Well, the theta is angle between A and B. Just like this form. The scalar product between A and B is A1B1 plus A2B2 plus A3B3. We will learn this later. So there are some special case. So if A and B are parallel, so the angle between them may be 0 or 180. So for like parallel vectors which are same direction, so their angle will be 0. So will be the dot product will be modulus A modulus B cos 0 will be 1. So will be written like that. And here's 1. 1 will be nothing. So if there are like parallel vectors, they are same magnitude and same direction. Same magnitude and same direction. So they will, like, we can just write as AA. So will equal to modulus A square. And their direction I, J, J, and KK, the dot product will be 1. So for unlike parallel vectors, the theta will be 180. You can see 180. The dot product A and B will be AB cos 180, so will become negative modulus A modulus B. Sorry, it's magnitude A and magnitude B. So if A and B are perpendicular, so the theta will be 90 degrees. So AB cos magnitude A magnitude B cos 90 degree, cos 90 degree will be 0. So the final answer will be 0. Okay, so is it confused? You see this I, J, J, K, K, or IJ like this? Is it confused? So we just go to the question. After you go to the question, you may not so confused. Okay, let's go. If A equals to 2i minus 3j plus 5k and B equals to 3i plus 4j minus 2k, so find dot product of A and B. So let me change the pen color. So you have method 1. Oh, sorry, I haven't read the method 2. Later I write it on the spot. The method 1 is use the letter I, J, and K. The dot product between A and B. So 2 times 3. So it will be 6. Negative 3 times 4 will be negative 12. 5 times negative 2 will be negative 10. So we'll get 6 minus 12 minus 10. So will be negative 16. And the method 2, like an alternative method, just to use the bracket form 2 negative 3 5 3 4 negative 2. 2 times 3, 6. Negative 3 times 4, negative 12. 5 times negative 2 will be negative 10. So final answer will be negative 16. use this bracket form is easier to see lah compared to this form with IJK1. You will not get confused easily. And for second question, given three vectors A, B, C, so find alpha if A and B are perpendicular and beta if A and C are parallel. Okay, so we go to AB first. So if A and B are perpendicular, so the dot product between A and B will be 0. So I write the equation, dot this equation will be 0. So 8 times 2, 16. I just use this. Negative 2 times 3, negative 6. 5 times alpha, 5 alpha. 16 minus 6, so will be 10. Plus 5 alpha equals to 0. 5 alpha equals negative 10. Alpha will be negative 2. And beta if A and C are parallel. So, just simple. A will be something will be 4C or 5C or 6C or 7C. But we don't know what's the number. So I just put lambda C. They are same direction. This A and C are same direction, but don't know which is longer, which shorter. So I just put lambda to represent a number. So A equals to A equals to C. Multiply the lambda inside. So negative for lambda I plus lambda J plus beta lambda K. So first we find the value of lambda. So 8, compare these two sides, left hand side and right hand side. 8 equals to negative 4 lambda. Lambda will be negative 2. Yeah, the lambda is negative 2. You don't you no write it also can. I just write it out here to prove that the lambda equals to negative 2. So 5 equals to beta lambda. So lambda is negative 2. So negative 2 beta. So beta will be negative 5 or 2. So here's the solution. Okay. So for the properties of scalar product, just now I said there are 6 properties. Just you need to memorize it well. How to memorize it? You just do more exercise. As you know, that's practice makes perfect. Yeah, this same magnitude and direction, so will be A squared. AB as is scalar, so AB equals to BA. A dot BC, so just multiply inside it, like multiplied lah. But the dot is not multiplied lah. A dot B plus A dot C. So alpha A dot B can be alpha bracket this or like that. And alpha scalar. So the 0 vector multiplied this vector will be 0 because it's 0. Okay, there are 5 questions. Okay, let's go to a question. So simplified A minus B dot A plus B. Okay, for this you just like factorize it. Factorize A times B, negative times A, negative times B, just like that, like factorize. The dot is like lah, just like multiplication. Just like only lah, but it has some difference lah, A, so will be A squared. AB minus BA, so this will be nothing. 0. Negative BB, so negative modulus the magnitude B square. And for B, A can be write as A dot C, B dot C, and here A minus A dot B, C dot B. Okay, this is a little bit complicated. The CB and can written as BC, so BC minus BC will be 0. So we just left AC minus AB. So we can take out the A dot C minus B. So for second, the magnitude of A equals to 3, magnitude of B equals to 5, and the dot product is 9. So find the magnitude of A minus B. For me, I use like the factorization, because in the factorization, lastly my answer will be have this modulus, the magnitude A, magnitude B, and the dot product. So square it, A and B, and factorize A square minus 2AB plus B square. So this A will start as 3 square, B is 5 square, and this dot product will be 9. 9 minus 18 plus 25, so will be 16. Okay, so if U, V, and W are three non-zero vectors, such as U plus V plus W equals to 0, so show that U, V equals to this thing. This come out from PSPN 2008. Okay. For me, you have give this hint, U plus V plus W equals to 0. For me, my method is I take out the W, because I see this U and V, the dot product between U and V. There's no W. So I take out the W, so easier for me to do. Minus U minus V, take out the minus. So dot product for these two W can be written as this W square, U plus V, so you'll get U square plus 2UV plus V square. So I see the 2UV. So I should take out the 2UV from the equation. So 2UV will become this W square minus U square minus V square. And these two, I move it to right hand side, so will become divide. This equation divide 2. This is the solution. Okay, the fourth question. If the magnitude of U plus B equals to 5, magnitude of U minus B equals to 1, so find the dot product. Yeah, this is the same. For me, I will prefer to square root the magnitude to find the dot product. For U plus B square, so will be 25. So U plus V times U plus V. So I get the first equation, U square plus 2UV plus V square equals 25. And the U minus V also same. I square root it. 1 square equals to 1. So I also get U square minus 2UV plus V square equals to 1. So I have these two equations. Okay, so what to do? So we need to clear this U square, V square, this U square, V square, because we don't know the value. So we need to do is clear this U square and V square. So for me, I use this first equation minus these two equations. This minus will be 0, will be nothing. So 2 minus minus 2 will be 2 plus 2 equals to 4. So 4UV, 25 minus 1 will become 24. So UV will become 6. And the last one, given non-zero vectors P and Q are perpendicular. So prove that. So for A, we need to prove that the magnitude square equals to P square plus Q square. Okay. So before that, because we need to factorize it. Yeah, we need to factorize it. So we need to know that we factorize the P square plus Q square. So we will get P square plus 2PQ plus Q square. So we have to know that when we factorize it, we will get this thing. For this, the B negative, P negative still also same, but this positive will become negative. So given that non-zero vectors, there are non-zero vectors, P and Q are perpendicular, so the product of PQ will become 0. So we factorize it, so we get this thing, the P and Q become 0. So we just left P square and Q square shown. And how to prove that P plus Q become P minus Q? So we do same thing with the factorization to the P minus Q. We will get also same P square minus 2PQ equals 0 plus Q square. So we just leave this thing. So as we just see the P plus Q square same as P minus Q square. So we just take out this square. We don't want this square. So P plus Q so equal to P minus Q shown. Okay, next we go to the angle between two vectors. Just simple, we just know that just now the scalar product AB equals to magnitude A, magnitude B cos theta. So we take out the theta. Will become the acos. This called acos. Acos the dot product AB divide the magnitude A, magnitude B. So we see a question. Find the angle between the vectors A and B. So we find the dot product. So dot product 2 times 3, 6. Negative 3 times 4, negative 12. 5 times negative 2, negative 10. So we'll get negative 16. And we need to find this magnitude of A and magnitude of B separately. So the magnitude of A will get square root 38 and magnitude of B will get square root 29. So to find the angle, so we across the negative 16, divide this 38 times 29. So I will get negative 0.4820. I across it, it will become 118 and 0.81 degree. Okay, just remember that the angle will be 0 to theta to 180. Just the angle will be in the first quadrant or second quadrant only. It will not exceed 180. Yeah. So we go to the last one, direction cosines and direction angle of a non-zero vector. So we consider the vector of OP when P is simply put as a point ABC. So if OP makes an angle of size alpha, this is alpha, beta, and gamma. with the x-axis, y-axis, and z-axis representatively. So you can see the x-axis alpha, y-axis beta, z-axis gamma. So the angle, size of angles, so just now I said between 0 and 180 degrees. So then the cos alpha will be the length divide the length and divide the modulus of OP, cos B, and cos beta and cos gamma. So cos alpha, cos beta, and cos gamma are known as the direction cosines. Their ratio will call as direction ratio, but mostly they won't ask this direction ratio. Okay, so we know the A equals to magnitude cos alpha, B magnitude cos beta, C magnitude cos gamma. So since A square plus B square plus C square equals to this magnitude square, just now this derived from the formula from just now. So then OP square will be OP square cos square A, OP square cos square B, and OP square cos square Y. This for just now. Just now you know AB. Yeah. So we take out the OP square, so will become cos square alpha plus cos square gamma plus cos square beta. Sorry. So OP square cancel, so we'll get 1. Okay. Okay. Just I don't know how to say what. So this OP square cos square A, so this get from A square. This get from B square. And this get from C square. And just take out the OP, come out and cancel the OP, so you'll get 1. Hence, the angle, the size of angle are known as the direction angles of OP with this. So if the cos square alpha plus cos square beta plus cos square gamma not equal to 1, so the vector with direction cosines does not exist. The two vectors have the same direction. It's the like this. Two vectors, they have the same direction cosines if they have the same directions, like this. You see these two vectors? So if you see, as they have the same direction, so they also have the same direction cosine. It's quite complicated, right? Yeah, but you do is quite simple. Just the theory is very complicated. So we go to the question. Find the direction cosines and direction angles of this vector. So to find the direction cosine, so we use this this red color formula. So let us find the magnitude 3 square plus 1 square plus 1 square, so square root 11. I let it as third form, so my calculation will be more accurate. The direction cosine of A will be the cos alpha 3 per third 11, this 1 per third 11, this negative 1 per third 11. So the direction angles of alpha, so just across it, across it, across it, across, across, across. So for alpha, I will get 25.24 degree, beta 72.45 degree, and this because it's negative, so 180 minus 72.45, so I will get 107 and 55 degree. It's just like that. It just the theory is complicated, but mostly the question will ask like this only. Just very straightforward. Ask you to find the direction cosines and direction angles. So don't get it confused. So here's n for 5.2, and we will proceed to 5.3.